In this activity, we're asked to find two different functions that could model the shot of a basketball into its net. And you can see, and we've discussed, that a basketball shot is the shape of a parabola. So we know this is going to be a quadratic function. We're given some information that the free throw line is 15 feet away from the foot of the basket, that the basket is 10 feet above the ground, and that the player releases the ball from a height of 8 feet. So this picture below is very helpful, and we can see how there are multiple ways for the ball to get in the basket. But let's draw our own diagram. I'm going to make this the player with the ball leaving the player's hand at 8 feet. The player is 15 feet from the basket, and the basket is 10 feet high. So we are hoping to model an equation that will get that ball directly into the basket. Now, as you can see in the picture as well, that could be a kind of flatter shot. You could do a big lob and make it really high. There are multiple ways to get there, multiple paths that ball could take. Theoretically, it could go straight across and be coming back down and go into it as well. So because this is a parabola, and we have some techniques to find the equations of parabolas on a coordinate plane, let's turn this into a coordinate plane. So let's make the player standing on the origin. So the ball leaves the player's hand at 8 feet. In other words, the point at which the ball leaves the player's hands is 0, 8. The ball travels 15 feet and hopefully lands 10 feet high. So the point of the basket is 15, 10. And we could have any number of vertices, or other points in between. But these 2 points give us a starting place to find the equation. And so we know quadratic formulas. We have standard form, y equals ax squared plus bx plus c. Vertex form, if we know the vertex, is y equals a times x minus h squared plus k. And factored form, y equals a times x minus p times x minus q. And that would be helpful if we knew the x-intercepts, or the zeros. But we don't know the x-intercepts. We don't know when or where the ball will hit the ground. And we don't know the vertex, because it could be anything. However, maybe you'll notice that we have the y-intercept, which is c in standard form. So we're going to use that y-intercept and substitute it in place of c in standard form, giving us y equals a x squared plus bx plus 8. We also have another point, 1510, that we can utilize, and we can substitute that into the place of x and y. So y is 10 equals a times 15 squared plus b times 15 plus 8. Simplifying, we get 10 equals 225a plus 15b plus 8. And just to get this a little cleaner, I'm going to subtract 8 from both sides so that I have my variables on one side and my constants on the other. So 2 equals 225a plus 15b. We've used all the information that the problem gave us, the 15 feet, the 10 feet, and the 8 feet. And we're still left with two unknown parameters, a and b. A couple of things is that we know that the parabola is going to be concave down. So that tells us that we want a negative a. And we can just, at this point, because we don't know A and B and we're told to find two different, we get to just pick what we want A and B to be. But we want to pick an A that's negative. So let's go easy and just let A equal -1. So if A is -1, then we have 2 times 225 times -1 plus 15b. And simplifying, we can solve for b. So 2 equals -225 plus 15b. Adding 225 to both sides, we get 227 is equal to 15b. And dividing by 15, we get b equals 30. B equals 15.13. And so now we have for an A value of -1, B would equal 15.13. And so we can substitute those back in for A and B into this form, giving us y equals -x² plus 15.13x plus 8. And that's one possible path that the ball could take. And now let's say we want to let A equal, let's just go for -15. A equals -15. So in the place of A, we have 2 equals 225 times -15 plus 15b. And we get, I don't know why I chose such a big number, but we get -3375 plus 15b. Adding that to both sides, we get 3377 equals 15b. And dividing that by 15, we get that b is 225.13. And so we could also have an equation, y equals -15 x² plus 225.13x plus 8. If you graph both of those equations, you'll be able to see that they both create paths for the basketball to enter the basket.